G'day. Welcome to Crystal Clear Mathematics, where it is easier than you think. I'm Graham Henderson. And right now we're in the midst of a series of videos describing how to analyse quadratic equations, like these ones, and graph their parabolas. And in particular, we're right now looking at how to factorise quadratics. Now there are a number of methods around to do this, but they're all variations on a common theme. And the common theme is to work out a product and a sum, what we call a PS method. And I'll have more to say on that in just a moment. The reason why it's so important is twofold. One, analysing quadratic equations is foundational to so many areas of mathematics. It pops up in probability, trigonometry, number theory, calculus, statistics, graphing, and the list goes on and on and on. It is very important that you develop this skill if you want to do much in mathematics at all. The second reason why I think you should watch is that I've looked at perhaps 20 or 30 other videos on YouTube to see if other people are explaining it the way I do, and they're not. Now, some people explain quite good methods, but I think I have something unique for you. So if you've been struggling with this, please keep watching and I'll show you a technique that just might make this a lot easier. First of all, just a little bit of a recap. You'll know that when we're analysing what we call a monic, that is a 1x squared, a monic quadratic, that we look at this number on the end and we look at the coefficient of x, and we're asking ourselves what numbers multiply to give minus 18 and add to give minus 3. This is our product and sum, multiplying to give this and adding to give this. A little more complicated when you have a non-monic quadratic, that is when there's not a 1 here, something else. And we know in this case that we multiply these two. 2 times minus 3 is minus 6. We write the plus 5 underneath. And we ask the question, what numbers multiply to give minus or negative 6 and add up to give 5? Now they're really not two different methods. This one's the same, except when you multiply the 1 by the minus 18, you still get minus 18. So we tend to ignore this step of multiplying the two extremes. But the big question here is, how do you do this? Now, not all students find this easy. Of course, I encourage you to learn your multiplication tables. So if you want to know what numbers multiply to make 18, it's 1 times 18, 9 times 2 and 3 times 6. To get minus 18 we have combinations of these, and students tend to come, even students who understand their multiplication tables, come unstuck when they start discussing negative numbers. So I have a method to overcome that problem, and I'll show it to you in 2 steps. Now the first step is not going to be new to you. It involves a case where all the numbers are positive. I've designed a spreadsheet that generates these randomly, and it looks like this. There's a link to it below this video, in the description below the video, and you can print a different page out every single time and practice this skill. You can even change the largest factor involved so that you can get numbers that are quite large, very large in fact. Now, I'm not going to take long on this because I know you know what to do, or at least I hope you do. In case you're a bit of a beginner, if we're looking for numbers that multiply to make 25, some people recommend listing them. Now 1 by 25 and 5 times 5 are the only combinations that really work, and we're looking for a pair that add up to 10, and you can see it's 5 and 5. What combinations multiply to make 48? Well, that's a bit more complicated. I'm not going to list all of them. Well, maybe I should. There we go. We're looking for a combination that adds up to 14. And if we look here, it happens to be this bottom one, 6 and 8. And here for 32, we would write out all the combinations to give 32. And we would find a combination that adds up to 12, which happens to be 8 and 4. Now, with practice, you won't do this. In fact, with practice, you should be able to do this in your head at fairly high speed. And that's why I developed the sheet. Excuse my ducking out of range. The idea of this sheet is that you can fold the answers, these numbers on this side of the answers, behind, and what you have are 10 examples just like these. In fact, these are the first 3 of my random ones here. Each day, if you like, or every time, if you're a teacher, every time in class you can give the class a new set of 10 and just say do these and make a race of it. Once students are comfortable doing it on paper, you can hold them up between, students can hold them up between each other, and one can calculate in their head the answers and the other can read off the answers at the back and check them. It's a tremendous little skill. I'm just looking at 54 and 15, so there's 9 and 6 and 7 and 1 and 5 and 7, and I'm calculating them as I go. But you should be able to, in time, do this mentally. Let's look at the case where we have negative numbers though, and for that I have another spreadsheet. This is where the trick, or at least this is where I have a method to make it easy. So let's have a look. Right, here we have the same kinds of number pairs that we're going to analyse. We're going to try and find a product and a sum in every case, but you notice that we have minus signs. And I've tried to get a jumble here from 2 negatives to a positive negative to a negative positive, and a 2 positives. So we got all the variants here. And I'm going to explain my method, and what it is this. It makes it a 2-step procedure. Instead of trying to find a positive and negative or 2 negative numbers that do a job, it allows you to find the numbers first and then choose whether they're positive or negative. So it separates the problem into 2 steps. And it does it in a rather peculiar way by associating the number on the bottom with the sign belonging to the number on the top. So I get my students to draw what I call a loop. And here's how the wording is very important. You must say this in your mind and train yourself to say it. What numbers multiply to make 14 and add up to make 9? Now at this stage I'm not concerned whether they're positive or negative. In fact, because these are both positive signs, they'll end up being positive, but trust me, this works. What numbers multiply to make 14 and add up to 9? Well, it's not 14 and 1, but 7 and 2 multiply to make 14 and add up to 9. Then we stop and ask, how do we get a plus 9 with those 2 numbers? Now, you know they're both positive. But the logic is, the biggest number must have the same sign, because it will take us into the positive or negative region, and the little number's not going to change that. It will move us around within that region. But it's positive, and of course we need a positive 2 to get up to plus 9 as well. Let's see how it works out with others. If it has a positive sign here, for example, we'd say, what numbers multiply to make 21 that add up to 10? Well, 3 7s. 3 and 7. How do we get negative 10 with a 3 and a 7? Well, a large number has to be negative. And what do I do to minus 7 to get to minus 10? I subtract 3. And you can see that if I multiply these, I get plus 21. And if I add them, I get minus 10. But this loop allows us to find the numbers first, then worry about the signs. We got another one. Here it is. Let's do this, and then we'll look at the minus sign. What numbers multiply to make 5 but add up to 6? Well, this is classically easy because 5 is prime. So it's just 5 times 1. 5 times 1 is 5, 5 plus 1 is 6. Now we ask the question, how do we get a minus 6 with a 5 and a 1? The big number 5 has the same sign, and from minus 5 I go down 1 to get to minus 6. Well, we've done 3 of them. Let's look at the ones with a negative. We draw our loop, and by the way, I teach my students when they write the numbers to keep the plus and minus signs just a little bit removed from the numbers to allow yourself some room to draw the loop in. That's getting a bit close, but we can still draw it. Let's ask the question, and this time it's worded slightly differently. What numbers multiply to make 8 but subtract to give 2? There's another way of wording this that I prefer. What numbers multiply to make 8 that are 2 apart? Means the same thing. 2 apart, their difference is 2. Well, 4 and 2 would fit the bill. They multiply to make 8, they're 2 apart. Now we look at the number at the bottom. How do we get a plus 2? The larger number must be positive to match. And from plus 4 I have to go down 2 to get to 2. And that's my solution. Notice the 2 steps. Numbers first, then we ask as a final thing where the plus and minus signs go. Try it 2 more times. I won't do any more examples. I think this will be enough for you to understand the technique. What numbers multiply to make 15 that are 2 apart? Well, 3 5s make 15 and they're 2 apart. And then now that we've got the numbers, we look for the signs that give us minus 2. Well, a big number has to be negative. And from minus 5 we have to go up 3 to get to minus 2. Problem solved. This one. What numbers multiply to make 14 that are 5 apart? So obviously not 14 and 1, has to be 7 and 2. How do I get a plus 5 with a 7 and 2? Well, the big number must be positive, and I have to go down 2. Plus 7, take away 2 is 5. And there's the method I encourage you to learn. I hope it's been worth your while waiting. Now, I've created a workbook, an Excel workbook, with basically just 2 worksheets in it, 2 spreadsheets. Now, you've already seen, I've held up a copy of a page, but right now I'm showing you on screen what it looks like on the computer. Every time you press the F9 key, it randomizes the numbers. And I'm showing you that now on both the tabs, on both of the spreadsheets. So you can print as many of these sheets as you wish, and they'll all be different. Also, up at the top, there's a little box where you can change the degree of difficulty, if you like, and that is the largest number. So if you change it to something like 35, you get some quite large numbers. If you want to change it to 12, so you're only using numbers in your multiplication tables up to 12, that will give you a good workout. Most of the examples I've used here are up to about 6 or 8. And you can change the level of difficulty for yourself, or if you're a teacher, for the class, and you can build up your skill level very, very rapidly indeed. And this is the work engine behind factorising quadratic equations. If you get good at this, you'll become extraordinarily proficient at factorising quadratics, I promise you. Now, 2 little pleas. First of all, if you're a primary school teacher, I beg you, please do this exercise with your students. As they're learning the multiplication tables, you don't have to do it with negative signs, but with the positives only. Teach them to learn combinations that multiply to give one figure and add up to another. This is a fundamental skill that will help them enormously with the high school algebra. The second plea is that if you're a high school student learning this skill, please go to the link in the description below the video, download this worksheet, this workbook from my website. It has no macros, it's quite clean, and print off some sheets and practice. And if you find that it benefits you, then please leave a comment below this video and say this was wonderful. If you find that there are some improvements you can suggest, then by all means add your comment and I'll do my best to accommodate you. I've basically nothing more to say, so I thank you for watching.